Okay, so in the third example, we have two prom venues that charge a rental fee plus a fee per student. The table shows the total cost for different numbers of students at Lakeside Inn. So Lakeside Inn is one of our venues. The total cost for students at Sunview Resort, so that's our other venue, is modeled with the equation y equals 10x plus 600. So before I forget, I'm going to label this Sun, so that's the Sunview Resort. And where this is headed is probably going to ask for the equation for Lakeside Inn. So before I even continue on the problem, I'm going to go ahead and get the equation of that one too, because 9 times out of 10, that's what they want. So I have lots of order pairs to choose from. I'm going to choose this order pair and this one. So I have my y1, y2, x1, x2, etc. So if I want to compute the slope, the first thing I need to do is subtract my y values. So I'm going to do 2700 minus 1500 over the change in x's, 200 minus 100, which is going to get me a nice friendly old 12. So I know that that is my slope. What I don't know is what the y-intercept is. So I don't know what the rental fee is for that company. I know it's $12 per kid, but that's it. So we're going to have to use our point slope form, right? And I think I'll go with this one for that. So I'm going to set up my y minus my y coordinate, which is 1500, equals my slope times x minus my x coordinate, which is 100. And I'm going to get 12x plus 300. Right, so that's a very valuable piece of information right there, and I'm going to write it up here because I'll probably need it. Right, and that's for the Lakeside Resort. All right, it asks which venue charges less per student. So this one is 10 and this one's 12, so Sunview. So my first answer is the Sunview Resort. And then how many students must attend for the total to be the same? So what's the magic amount of kids where you're going to get the same outcome? So all that means is you take the formula for one venue, and we want to know when that outcome is going to be the same as that of the other venue. So we write an equals between them, and then we simply solve. So it looks like we're going to get 150. All right, so that would be my second answer. So normally when we're in class, I would have my students kind of break apart and work with a partner and see if they can answer the following questions, but obviously we can't do that right now. So we have a company, they purchase a copier for $12,000, and every year that copier depreciates. So what we're going to do is write a function to represent that. So it is a linear transition. So truth be told, we're just going up a year every time, and I just want to know how much is it changing each year. So if I just simply subtract these, 12,000 minus 750, I'm going to get $1,250. And the good news is I already know the y-intercept. It says right here the starting price was $12,000, and that's what y-intercept means. So it does say write a function, but we would like to use the letters v and t. So v as a function of t, and all that means is you write v of t. So it's going to be our function notation, but instead of f of x, it's v of t. So that means anywhere you see an x normally, you're going to replace with a t. So we are basically going down in value, $1,250 every year, and our starting value was $12,000. All right, so letter B, I'd like you to try letters B and C on your own. We're going to be graphing the function and then seeing why you think it might be called a straight line depreciation. And then it's going to ask you to interpret the slope, once again, in context of the problem. So I'm going to go ahead and pause my computer, work up my answer key, and then I'll unpause and show it. All right. So I went ahead and I started at 2,000, and then after that I counted up 1,250 to make my life a little easier. Counted by ones, plotted the points, and my reasoning for straight line depreciation would simply be because it's decreasing in value at a constant rate. So that constant rate causes a linear function. And then letter C, all I need to do is throw in the fact that it means down $1,250 every single year. So every year depreciates that much more. Lastly, I just wanted to review a vocab phrase with you and then a new vocab word with you as well. So if you recall line of best fit in Algebra 1, it is a line, obviously, so it's a linear function that most accurately predicts what's going to happen based on the majority of your data. So what that means is if you plot all your data points, they make a fairly strong line. That line that appears to be the strongest line of all your data is called the line of best fit. The correlation coefficient, that's going to be new for you guys, okay? That is the R squared value. Now, you're not going to know what this means yet, and that's okay. It's a feature on the graphing calculator that we're going to learn actually here soon. But for right now, you just need to know that R squared is called the correlation coefficient. So when you see that, that's what it's called. What that does is it measures how strong your correlation is. So if you were collecting data and it made a picture like this, okay, that looks like an uphill correlation, but the points are so far spread apart, so it's probably not going to be a very strong one, whereas if you had something like this, right, those points are really close together, so that's going to be a much stronger correlation. So what your calculator does is it actually gives it a percentage on how accurate each of these is. So this guy right here would probably be like a 60%, whereas this guy would probably be maybe an 80% or higher. So if you ever get an R squared value of 1, that means your graph is 100% accurate. So if it makes a prediction, it's going to be right based on the math of all the data that you plotted. All right, so closer to 1 is good. So if you got 0.96, that means it's about 96% accurate. So your line of best fit is about 96% dependable. And then just a couple reminders. When you're writing the equations of lines, so linear functions, if you're given a slope and a y-intercept, you're smart to use slope-intercept form because that's the info you need. If you're given a slope and a point, you can use point-slope form. Or if you learned a method in the past that works for you, that's great. You're going to see me use point-slope form. And if you're given 2 points, you're going to have to find the slope first, and then what I would do is use point-slope form with either of them. So you can do the 1s or the 2s. You cannot do x1 with y2. That you're not allowed to do.